ever thought about what would happen if the Earth came into the gravitational field of a black hole? Think about what would happen to our planet, the amount of gravitational force exerted by the black hole on the Earth. Today, we're going to be calculating exactly how much gravitational force the Earth would experience. In order to calculate the amount of gravitational force in between the Earth and the black hole, we need to use the equation for Newton's law of gravity. Here we have F for the gravitational force, G is our gravitational constant, M is the mass of the larger objects of the black hole, little m is the mass of the smaller objects, the mass of the Earth, r is the distance in between the objects, the distance in between the black hole and the Earth. This equation allows us to calculate the gravitational force between two objects with a mass, and it shows us that the amount of gravitational force experienced between these objects is proportional to the mass of the objects. In other words, the more massive the object, the greater the gravitational force between them. It is an inverse square law, which means that as you increase the distance between the two masses, so if you increase the distance between the Earth and the black hole, the amount of gravitational force between the two objects would decrease. For the values that we're going to be using for our calculation of gravitational force, we obviously have G, our gravitational constant, M for the mass of the black hole, little m for the mass of the Earth, and R for the distance in between the Earth and the black hole. Now, this mass of the black hole is the actual mass of the closest known black hole to Earth, and this distance is the equivalent to 30 light years. Now, the closest known black hole to Earth is actually 3,000 light years away, so I have essentially brought that black hole 100 times closer to the Earth for this calculation. When we put all of the values into our equation, we have the answer that F, the gravitational force, is 1.083 times 10 to the 11 newtons. That's the gravitational force acting between the Earth and the black hole. How fast would the Earth need to be travelling in order to escape from the gravitational force being exerted on the Earth by the black hole? This value is called the escape velocity, and it uses an equation which you will need to be able to derive and also apply in your high school physics exam. We're going to use the conservation of energy to derive our equation for the escape velocity of the Earth. We know that initial energy must equal final energy, that's conservation of energy. We know the final energy must be zero, as we're trying to find how quickly the Earth will need to travel to escape the potential of the gravitational field of the black hole. So we can put this equal to 0. We then substitute in our equation, so we have half mv squared for kinetic energy and gmm over r for our gravitational potential energy. The masses cancel out, and with a little bit of rearranging, we have our equation for the escape velocity of the Earth. V equals the square root of 2gm divided by r. So we put our values into our escape velocity equation, and we come up with an escape velocity of 101 meters per second. Now, this means that the Earth would be pretty much fine, as it is a very low velocity compared to how fast the Earth is traveling in orbit around the Sun. Thank you very much for watching the first ever video on Fierce Physics. If you enjoyed the video, please hit the thumbs up button. If you found it useful, then consider subscribing. Also consider following me on Instagram at Fierce Physics and sharing Fierce Physics with your friends. Let me know in the comment section below if there are any topics you'd like me to cover. Until next time, bye!